Everything's data at some point. Yeah.
Hello, everyone. Thank you for joining DataCon 2022. Welcome to BI Reporting Business Use Cases track. My name is Hari Krishnan, your host. Our co-hosts today are Courtney and Viva. Please be mindful of COVID regulations and keep your mask on if you feel like. Also, silence your phone during the session. This session is currently streaming via Zoom and will be recorded. It will be available online in a few weeks. Today, we have our guest, Jaysen Gillespie, and he'll be talking about real-world consumer segmentation. One key takeaway from today's session is that doing analysis is their specialty as data analysts, but they are often judged based on the business interpretation of their work. Jaysen is fine with interrupting him throughout the session if you have any questions. Jaysen is a Southern California analytics, marketing, product, revenue, and data science executive, overseeing all aspects of analytics and data science for RTV House, a leading digital marketing ad tech company. He has 15 plus years of experience in technology and analytics leadership roles. He has managed global teams both on a remote and in-office basis and specialized in finding ways to bring data to the entire organization. He's a big proponent of making data both useful and fun. One fun fact about Jaysen that he wanted to share is that he has been quoted in the LA Times regarding Michael Jackson, but not regarding data. Without further ado, I'll hand over this to the speaker. Thanks for being here, Jaysen.
Thank you for that introduction. I'm not sure how I'm going to live up to that. Be careful what you put on your LinkedIn. But it's great to be here. It's great to be back in person at DataCon. We are going to talk about a few things. I think there'll be something for everyone here because this is going to follow a project sort of from beginning to end where Hari just mentioned, sometimes as data analysts, we're very good at analyzing data. We're very good at doing models, but what are our business users or our customers doing with that data? If it falls off there, we might not get the full credit or the full value of what we do won't be observed by others where that observation perhaps matters. So we're going to talk about that from end to end here. As he said, sometimes I ramble on like a freight train. If you have a question, just throw your hand up. I'm happy to recognize you, or you can wait till the end and I'll open up for Q&A then. All right, so without further ado, I work at a company called RTV House. We're actually based out of Poland. I put a map here with Poland because it turns out only 1/3 of Americans can find Poland on a map. Not you guys, because you're not that 1/3. You know, you're data people. You're still here at 5 o'clock, which is awesome. Thank you for coming this late in the day. And probably most of you didn't know where Poland is, but nonetheless, we're a European company. We have about 1,000 folks around the world. And we use deep learning, and deep learning is sort of a fun marketing way of saying neural networks in order to make predictions that are relevant for advertising, such as if I show you an ad, will you click on it? If you click on it, will you then go and buy something? A lot of our customers are people that sell things online and want to use ads to sell more of their products and engage a company like us. If you happen to be in advertising or media, we're what's called a DSP or demand side partner, a way of buying ads at scale across the internet. And what makes that interesting from the data standpoint, and if you're really interested in big data, going into online advertising is one of the best places you can be. Probably the platforms, the Googles, the Facebooks, the Twitters of the world, and then people like us, or my prior company was a company called Criteo. Companies that have to show ads millions or billions of times a day have to handle extraordinary amounts of data. Question, yes, sir. Yeah, Rubicon Project, they're the other side of the house, whereas we're what's called a DSP. They're an SSP or supply side partner where they're more selling ads. So we might buy from Rubicon. Rubicon would say, hey, do you want to show an ad to this person? And they would go out and talk to a bunch of potential buyers like us. And we would say, sure, we'll buy that ad. We'll pay you $1 to show 1,000 of those ads or something. So yeah, good point. There's a supply side here that also has an extraordinary amount of data. If you like big data, and if you have any interest in marketing at all, the online advertising space is still a very interesting place to be, especially because Google, which owns the Chrome browser, hasn't fully figured out what they're going to do about the cookie situation. They say they're going to sunset third-party cookies. They've now delayed that yet another year. So now we're looking at Jan 1, 2025. We'll see what happens. Nonetheless, it makes it interesting. So a demand side provider, basically a mechanism for buying ads on the internet. So we'll serve billions of ads in a year, and we'll log all of that because we'll need to see how they do. And those ads will generate millions of clicks. This is just to give some idea of the kind of volume of data. It's probably much higher than this because I often just deal with the US market. So this, we sell to businesses, and I called this consumer or user segmentation because sometimes those businesses come to us and say, hey, RTB House, you know a lot about data. Help us with our data. So this is actually a case study about one of our clients. So I can't say the exact name, but it's an app. We deal with companies who have websites and sell things and also have apps and either sell things or want to generate leads or have certain actions that they want taken. So this is about a consumer app that people use to make their shopping experience a little bit better. And the problem with that is when you talk to folks at these companies, they all have some idea about their users. This group thinks our users sort of look like this. This group says our users look like this. This group says something over here. If you put it all together, you're probably getting an elephant, right? If you feel the leg or the tusk or the ear, it all feels a little different. How would we solve that problem in this room? With data. That's the way I've always felt. It's reasonable. A lot of analytics people think that way, but that's not universal. Sometimes you'll have people who are more interested in intuition or maybe a very small focus group or other mechanisms than using big data. So analytics had some ideas about who the best users were. Marketing had some ideas. There are different viewpoints. Great, we're happy to step in because we think this adds a lot of value. For example, we might be able to challenge existing thought in such a way that we correct a belief that's out there. And if we can correct a belief and make people take different business actions that are better for their business, then that's valuable. We might be able to determine, what do we build? What's our product strategy? Our marketing strategy is usually heavily affected by really understanding who our best users are. And ultimately, finance needs to understand, how is our business going to perform better? So there's a lot of reasons why we really need to know our users, our types of users, and hone in on how those types are different. So we always think just starting with exploring data makes a lot of sense. And the easiest way to do that are just basic one-dimensional pieces of analysis, right? Because you can do it with any tool you have. Everybody has a favorite tool. It could be Excel, it could be SQL, it could be something like R or Python, or even just going back to good old coding if you love C++ or C, or some guy even mentioned COBOL in one of the keynotes. If that doesn't give you nightmares, then you're not old enough to have them. But yeah, if you're still doing COBOL, my hat's off to you. But in any case, there's a lot of different ways that you can pull sort of one-dimensional data. So we always start with building some basic facts. And this was what was leading to the root of the problem. What is wrong with this? You've got one group of people, marketing usually, who are like, get me new users, get me users, get me users. And they're really focused on new users. And they discovered that they could go out and get people that were 19 or 20 years old very cheaply and very easily. And so they were bringing these people in by the boatloads and saying, this is amazing. We love Gen Z. We love really young millennials. On the other hand, you had analytics, product, and some other people saying, but are they using the app? Because if you don't use it, you don't generate any money for us. And therefore, we're spending money against a user population that's maybe not ideal for us. And the two curves were almost polar opposites. Low percentage of the distribution of new users being older, but older users were the ones who were generating all the activity. So this was the fundamental disconnect. This one simple analysis opened up a host of other questions and really lit a fire underneath both analytics and marketing to really better understand, well, who on earth are these users? How can we create segments or different types and really understand them in more detail? So just as we did here by one simple dimension, which was age, you could take lots of other dimensions or features or attributes, whatever you want to call them, and do the same sort of breakdown and understand things. But really, when you do that, you're still a little bit short, because what you're doing is you're effectively looking at a full color image on a CMYK basis. Like, my wife's a graphic designer, so a little bit of it is rubbed off. And you can decompose any image into CMYK panels, which are cyan, magenta, yellow, and black. And every one of those might tell you a little bit, But I stared at this and I couldn't tell what this thing was. Some of you may know what this is already. If you do, then awesome. But it's a butterfly. But you only get the full perception when you really bring everything together. And that's really the difference, a visual representation of the difference between thinking in a univariate world and a multivariate world. How do we combine a lot of different factors to give ourselves the full picture? The great thing is, now moving on up, as George Jefferson would say, we're going to go from ETL and EDA, which is sort of extracting, transforming, and loading, and exploratory data analysis, which is, again, where we're spinning data, cleaning data, pivoting data, building basic understanding of data. Just reading it row by row in Excel sometimes is really helpful. Now we're going to move from that into modeling. Modeling is often a point where we become very multivariate. Maybe it's a regression model, maybe it's a cluster analysis, maybe it's deep learning like we do. We're going to move from just exploring into model. And there are fundamentally a few different ways you can classify types of models. One that you'll see a lot in data science is supervised and unsupervised. I know unsupervised sounds cool because it sounds like you're doing something you're not supposed to. It's not as fun as that. It's fun, but it's not that fun. So supervised, I think of as you need to have the answer in the back of the book for these things to work. And there was a talk earlier that talked about taking 20% of your data and putting it aside. And that's sort of your test bed, and then having 80% that can be your training data. But to train your model, for example, with a logistic regression or linear regression, you need to know how those folks performed. You need to know the answer or what you're trying to predict. In unsupervised learning, you don't need to know that because you're not making any a priori assumptions about people, which is why when you need to take a population of users and sort them into like groups so that you can do segmentation, cluster analysis works really well. You really don't need to have much idea about what makes these people come together or be separate. There are a few design decisions you have to make. We'll talk about one of those in a moment, but the algorithm will figure itself out on a pretty straightforward basis. Deep learning, for example, what we do at RTB House can sort of be either, but because of the nature of what we do, we try to predict if people will click on an ad. We use deep learning in a supervised fashion where we'll ask the network to make a prediction. Then for some slice of our population, we'll check it against what they really did. So there's supervised and unsupervised. And we decided to go with an unsupervised approach because we don't really want to have the answers to begin with. So we used a technique called k-means clustering, and this is like the most gentle of gentlest introductions to clustering users. It's super easy. You can do it right in Python. You could probably just about do it in Excel, actually, if you really teed up all the formulas right. You can almost do it by pen and paper if you had to. I'll briefly go through it because I think it's so simple that it's worth walking through. You take all your points, and you decide, how many clusters do I want? That's really your one main design decision when you're running this thing. And sometimes that's where you go back to the marketing team or folks who have been deeply enmeshed in understanding your users, because they'll have some idea and they'll say, oh, we think we have 2 types of users or 3 or 4. Much more than that, it tends to get a little murky, but usually 2, 3, 4, maybe 5 types of users, depending on how big your business is. That's really your one design decision. What is that end value? How many users? In this example, we've got 3. And you just randomly pick 3 users or 3 data points as your initial center points for each cluster. And then you can see that we have the first green, blue, and red shaded areas where they're just saying, where's my closest center point? Then find the new center point based on everybody who's in each of those regions and iterate on it. Wash, rinse, repeat until the center points don't move. That's convergence. The algorithm stops, and you've got your clusters. Looks pretty simple. It's actually very simple to do in 2 space, which we visualize it in. Your data will hardly ever be just 2 dimensions. There may only be 2 dimensions that are germane, but initially, at least, there will probably be a lot of dimensions. That's what makes it fun. If it was just 2 dimensions, you could almost just print it out and draw lines and you'd be done with it. If you have 8 or 10 or 200 dimensions, that's where it's hard to do on pen and paper, and the algorithm will really help you. So let's talk about that. What happens when you do have a ton of different dimensions? Now, this thing relies on a distance formula, fundamentally, for a few reasons. One, you're computing centroids, and you need to know how far apart things are. So it's good old Pythagorean theorem, except instead of just a squared plus b squared, you've got one of those add-ins for each and every dimension or factor that you're pushing into the model. So for that reason, it's important to really think about the data. Of course, like a lot of these models, the data has to be numeric in some way. So what we did was we took the features, the raw data, and we started thinking about, what do I need to encode? Well, you have an age. Age is great because age is numerical. You have a gender. Gender is not numerical. We encoded it based on a brief analysis that showed that only something like 20% of these users self-identified as male. And so that was kind of a minority population. So we just sort of said, okay, you get a 1 if you're male and a 0 if you're not, or self-identified as male. Race is the same way. We asked people to self-identify, and most of the people self-identified as white. So it was like 1 for non-white. Again, this was the population of this particular app, which doesn't necessarily reflect the demographics of the US. We learned pretty quickly. And also it skewed a little bit older. So you have to take into account that the US demographics shift quite a bit as you go from people that are in their 70s to people that are in their 20s. Household income is great because it's numerical. Number of children, generally an integer. Zip code, tricky one. It's an integer, but it doesn't really act like one. So in the end, what do you think we did with zip code? Any guesses? That was a great idea. That was how we started. Like, let's put everyone in, say, Southern California zip codes over here so we could make a category and make buckets. In the end, it was too hard to do that, and we ended up just sort of pushing it to the side. But if we had more time or in a second version, we'd be right there with you. Find some way to make it a bucket that's realistic. And then years of education. People say they have a master's degree or a PhD, so we sort of encoded that into something numerical, which was how many years we thought it would take you to get to that point. So we threw all this into the model, and kind of a surprise came out. And let me tell you, surprises are great when it's your birthday. They're not so great when they come out of a Python model, because it's usually not the kind of surprise that's going to help you. What could possibly go wrong here? It turned out the surprise was the model said the only thing that matters is household income. And it basically created groups of people only by income. And we went back and looked at it and said, well, of course, because to the model, it only understands the number. It doesn't understand what it's tied to. So the difference between a 20-year-old and a 60-year-old is 40 units of something. And that's the difference between a $50,000 house and a $50,040 house. So a $100,000 house, of course, was skewing that way off, and you're using distance formulas and all that. So really important lesson. You've got to normalize your data before you throw it into something that uses a distance formula, such as a k-means algorithm. Super cool, not hard to do. In fact, there's a really cool Python procedure called sklearn.preprocessing.standard_scalar. That can be your new BFF, because once you use that, it can take all your variables and sort of normalize them using something like a z-score, or the number of standard deviations above or below a center point, which works really well because you may remember from stats what fraction of a bell curve falls within 2 standard deviations of the mean. Everybody? 95, thank you very much, and 68 for 1 standard deviation too. So that falls off pretty quickly, which means you're going to normalize most of your data points to between -2 and +2, which is awesome because it prevents that $100,000 household from really skewing things off. We ended up dropping zip. Some of these other things like children, we divided by 3 just to shrink their effect, because we didn't want people that say had 8 kids or something to really skew it off. So we capped some things, we manually normalized some things, we standard scaled some things using z-scores. So we took a number of transformations in order to try to make the data better for our model. It's not that it was wrong or that there were a lot of errors or holes in the data, but even with good, clean, well-structured data, it didn't work the first time because we didn't standardize, we didn't scale. So note to self, standardize and scale. So a lot of people ask as a side question, well, if unsupervised doesn't require a training set, why wouldn't we just use it for everything? And one of the reasons is because you have to prove things, and sometimes you have to prove that there are causative effects between X and Y. And supervised models, such as a regression, help you do that because they give you things like p-values, for example. We don't care about p-values right now. There are other measures of kind of the goodness of our model for doing these kind of automatic segmentations, but we're not like testing a drug or doing something where if things go wrong, lives are on the line. In the worst case, maybe someone doesn't click on an ad. So our standard for error is a little lighter, which also leads us to an unsupervised approach where we can just look at the results and say, hey, it looks good to me, maybe while sipping our tea like this famous actor. So the other nice thing about k-means is that you don't have to make a lot of super detailed design decisions up front. As the person who's sort of overseeing all the modeling and executing this, there's often decisions you have to make, and a decision at some point is likely to be questioned because that's the nature of life. Everyone wants to know, well, why did you choose that? So if there are fewer decisions, that's fewer things to question and therefore fewer things for you to have to justify. Awesome. So with k-means clustering, again, one of the major decisions is how many different clusters do you think there might be? Less is more, often people say. Use the minimum that you think you can get away with. How much do you really gain by doing another cluster? Or ask the business, how many different types of users do you think we have? A wonderful thing, I love the name of this, it's called the elbow method. We all know this because as far as I know, you all have elbows. And so you can simply look at where that curve starts to flatten out. And for example, in the purple line here, you might say, all I need is 2 clusters, because when I go to the third cluster and I look at some measure of error, which is a sum squared distance of how far each point is from its centroid, I'm not really getting much better by going to 3 and 4 clusters. In the red line, it's a little more debatable whether you'd want to do 3 or maybe stop at 4. The great news is this algorithm runs really fast. So you can run it, and if you don't like what you get, you can try it with n+1 or n-1. And I'd encourage all of you to do that. One of the beauties of this is you can play around. You can get your first set of results, and then you can tweak some of your inputs and see what happens. So we ended up going with 4 clusters because I think that the red line reflected the situation we were in. We felt like going to 5 would just muddy the waters and probably split apart some groups that were fundamentally quite similar. So we went with 4. And we said, great. Is this where we break out the old $.drinks.favorite? Little Jaysen for anyone who loves pulling that out of SQL. And by the way, you ought to know how to do that because in our data, sometimes your data engineering teams get busy and they literally just make string fields in your database and they throw Jaysen as a string into it. If you're using something cool like BigQuery, it helps you with functions like Jaysen_extract, another one of your friends. But nonetheless, no, you don't get to break out the class A Azul right now because how do you know if what you did is of any use? Ultimately, you finished a modeling phase, but there's a lot more important things that need to go on to have a model output turn into value, really for your own team, but also for those who you're supporting. So yeah, you get this great thing that tells you a segment number, really is the output, segment number 1, 2, 3, or 4, and then you've got this huge data table. So in my view, that's all cool, but the real fun is just about to begin. And I've tried to lay this out through the phases of what you would do with some estimate of the amount of time involved in each one, because a lot of people will talk to me and say, I want to be a data scientist. I said, yeah, me too. When I grow up, I want to be a data scientist. The thing is, I keep getting paid to have jobs where data science is about 8 to 10% of it, which is that light pink run model, and data analysis and manipulating and cleaning data and talking to people about data and talking to business people and interpreting things is about 92% of the job. So there are jobs where you can go and literally just run models all day, but that isn't what a lot of jobs are. So it's interesting to think about what is the kind of role you might want to have eventually too. I would argue right now you are here, you've run the model, and it's time to interpret. What does this mean? How do I make sense of everything that's come out of the model as an analyst? And then how do I take it over to the business teams and talk in terms that they can understand? And then someone's got to execute on that. And that's not always the job of analytics, but sometimes it can be, and that's fun too. So one of the things that's great about cluster analysis is we can now take that cluster number and use it as a way of aggregating and finding all sorts of aggregate metrics by cluster. That will help us better understand each of these segments. And we can ask all sorts of cool questions, like which features differ the most across segments? Are there some features that don't matter, like zip, because we couldn't find a way to deal with it? Maybe something like educational level doesn't matter. Do we think that how we encoded the data failed us? Yes, we saw that with dollar income. We had to re-encode that as a scaled score. Do we see one or two features that seem to be really driving things? And often that's the case. There's one or two or three that really, when you get your hands around those, that's what's driving which bucket people end up in. And then should we rerun with different numbers of segments? So analytics, we love to say things like, hey, segment 2, their average income is 1.6 standard deviations below the mean. The problem is we get that reaction from the marketing team. So we stepped back and we said, all right, it's 5:24, we're having the meeting with marketing, they probably don't want to be here. Let's make this interesting for them. How can we better align with how they think and maybe reskin what we're doing? Well, the first thing is, let's think holistically. Let's not cite one data point. Let's build a story about who these users are by segment. So if we start looking at these segments, things pop out at us, right? Segment 1 was 55% boomers, some younger folks, Gen X, millennials, relatively top 50% of income, 75% of them, so relatively well off. Some college, mostly married. Compared to like segment 2, which was a good bit younger, mostly Gen X and millennials, a good bit better off. 92% had income in the top half, mostly college grads and some married, and so on and so forth. And so this starts to build a much more robust look at each of these segments, and it lets you go from just data tables and data points into really understanding how the algorithm sorted people. You can already get a feel for this. You can say, well, it certainly uses age as a major piece of information. And it looks like income is really important too. And marriage is kind of in there, and maybe education, but maybe age and income are more important. And there's probably 8 or 10 dimensions, and some don't matter as much. Yeah.
So when we're building these insights, kind of create the story for them, how valuable is that actually to find a typical member of that profile of that.
So good question for folks who are only hearing through here. I'm going to repeat the question. The question was, how valuable is that actual centroid, which will be an X dimensional data point, where X is the number of features that you fed into the model. How valuable is that for thinking about the totality of that centroid? And I would answer it sort of saying, generally speaking, I think it's quite valuable. And the reason is because it defines the cluster. So that is the point to which each member of the cluster is closest. So from that standpoint, I think it's very valuable. Whether you have to sort of temper your enthusiasm for that statement is based on, well, how far away from that are these folks really? So you would probably want to run an additional analysis where you would look at like, what is that average distance? Do you have a lot of people that are, let's say, like relatively close to that cluster, or are people like really spread out from it? So I like it, but I would want to check and try to have some understanding of the distribution of how far away each data point is. Good question. Okay, so here's an example of flattening our view into 2 dimensions based on those 2 dimensions that we theorized might be highly valuable, which are age and income. And you can see what we did was we sort of took those centroids, flattened it into just the 2 dimensions that we think really mattered, which were age and income. And then we said, you know what? Everybody loves names. We're not the naming team, but we can at least come up with something. So for the older folks are sort of settled and they're doing okay, we call them senior stables. And then for these sort of mid-aged folks that are like 40 and married and make good money, they're thrivers. And then you had the counterbalance to them, which unfortunately folks that weren't doing so well and were having some struggles, those were the mid-age laggers. And then we had like a young and struggling segment. And a lot of people, when I give this talk, especially if they're like 25 and they're a data analyst, they're like, well, where would I be on here? And I said, well, you're not on here because you're young and doing well and you don't use this app. And remember in that first slide, that was because people that are 25 only generate like some small percentage of this app's usage and revenue. So you don't necessarily have to be on here yourself. You just have to be able to understand the data and let the data lead you. In fact, it was that particular bias that led this particular app company so down the wrong path. The marketing team was a bunch of well-paid 26-year-olds. So they thought the world was well-paid 26-year-olds, and they thought that that's who was really coming into the app and generating value. They're smart folks. They totally understood when we presented this, but sometimes our own biases affect, even our thinking around business, and analytics is a great way to try to step away from our own personal biases that we all have one way or another. Okay, so what did we do next? We went back and we looked at major KPIs for our business, such as profit, revenue, how often people open the app, how often people use the app, things like the number of days between usage of the app, the number of different stores we may have seen people at in the app. And it was very instructive because we could take, for example, everybody who fell into the senior stables and say, wow, these folks buy 10 things a month, they have 212 app interactions, versus say the mid-age laggers, which was our worst performing group because they only buy 4 times a month and only have 112 app interactions per month. And when you can take your segments and tie it back to those real world pieces of your business and usage of the app, it really helps people like your product development team, because they might say, wow, maybe there are ways we can change the product to better service those groups that aren't using us as much. Maybe we should go do a product focus group just with people in the mid-age laggers group to understand why they use the app and what works for them and what doesn't. Or maybe we want to lean in more to senior stables and go find more things in the app that would appeal to people that are 65 instead of 25. There's all sorts of ways you can take this data and use it in a product development and marketing capacity. The other thing that's really nice is none of the code is really super duper hard here. So once you get this in Python, it's relatively easy to update. And you're probably going to want to update this at least once a year, if not like 4 times a year. It's a nice thing to update quarterly, because then you can sort of have your quarterly version of your segmentation. And you can look at how many people are in each group and how the distribution of group members is changing over time. Do you have a question?
So here, they are based on family matter, right? With an event-based updates, such as like essentially feature comes up in the app, so it could change this kind of behavior.
Yeah, a new feature could change behavior. Also, like this app happens to have high churn, so the population changing and the makeup of the population changing, we thought was actually the biggest issue why they'd want to update it. But you're right, sort of I see some of the subtext of what you're asking is, why do I need to update this if a 29-year-old is still 29 or 29 and a quarter? Some of these attributes are slowly changing. The other thing is people's attributes change a lot, not their inherent attributes, but attributes like their income, or they acquire more education, or they get married, or they have a child. There are things about people that are really impactful that do change a lot over time. And then finally, there was a last little box I had in the timeline about implementation. And that's not always something that analytics does, but there's always an analytical component to implementation, especially with a cluster project. Because once you do these, business users and management is going to want to see how they're changing over time. Great opportunity to work this data point into your dashboarding. So get it in your data warehouse. You'll get data engineering to open up a field for you that's something like cluster number, load it up, start bringing it into your Tableau or your Power BI or whatever you're using for reporting. And then you can have just another way of socializing it around your organization. Marketing will go out there, they'll create formal personas. They can hopefully better message to people now that they understand the groups. Someone like a finance might want to assign a total value or lifetime value to each of these groups. Product, I mentioned, could connect with them directly. And then your role as analytics is to report on it and to make it known and to be a general kind of evangelist for using these segmentations and extending the work that you've done. Happy to open it up to any additional Q&A at this point. Mm-hmm. So great question. The question was, would changes in the distribution or other factors change the method you would use? I don't think necessarily, but I think that there are probably other methods that might want to be considered. K-means is often like clustering for beginners, and we're beginners, but we're not, hardcore PhDs in data science. We know enough to be dangerous. And it's a real gentle, easy kind of algorithm to get started with. And importantly, it's easy to explain to others in case a CEO or CFO wants to understand how we did this. Mm-hmm. So the question was, thinking about starting with a larger number of features, 10, 20, 100, the question, I believe, was, if I heard you right, does that larger feature set tend to stay in there, or do people tend to focus in on one or two? And I think the answer is probably closer to the one or two, because it's the old 80-20 rule that 80% of the value is driven by 20% of the data, and that's true for features here. Usually there's one or two or maybe three that drive the segmentation in my experience. Also, when you get out into the world of non-analytics people, it's hard for them to think beyond 2 space. Some can think in 3 space, but certainly presenting 5 or 6 or 7 dimensions gets challenging, really for anyone, but certainly for non-analytical folks. Yeah, so example was brought up, could you use like a decision tree approach? I'm not sure if you need, that gets into the supervised versus unsupervised, right? Because usually those, you're trying to split groups based on minimizing some sort of difference, which is conceptually similar to how the clustering works. So there might be a way of doing that with some sort of decision tree approach that could be interesting too. I think if you're really into data science, a cool thing to do would be take 2 or 3 modeling approaches on the same data and see, does it give you the same answer? Then you'd really be confident that this is a good way to do the segmentation. Sir?
So, talk about could it be like a you heard that term before, right?
I'm sorry, what term?
Like useful metric, you take the smallest outside catchment cluster compared to the rate of distance and third ratio of to see like individual components, like the label.
Yeah, so the question was, are there other measures that might be better than just like the sum squared distance? And yes, there are. There's some good information online. And thank you for mentioning the other one that I think people use a lot is called silhouette width, I think. Silhouette width. So you might want to look that up. It's another metric that you can utilize. I'm not an expert on it, but I read a little bit about it and it did seem reasonable. We didn't dive into it yet, but again, just as you might use multiple models, multiple sort of flavors of the model might be another interesting approach. Mm-hmm.
So we can take one last question.
Okay, last question. You're the lucky winner.
So what action was taken based on what is that
Yeah, so you hit the nail on the head. The #1 action was how the app company would go after new users. So from the very first slide, of course, it was you wanted to go after much older users, but it allowed them to personalize the marketing against that segment. So for example, you're not going to show creative of a 31-year-old woman out at Coachella because you're marketing to a 66-year-old in Des Moines who's never heard of Coachella. You're going to change the creative, but you might want to use that same imagery for a mid-age thriving segment. So you're going to start taking your creative even and have it informed by this. You're going to take your targeting and have it informed by this. You're going to take the product team and have them pick up the phone or email or however they want to start getting in touch with 65-year-olds and understand why they love this app so much. Analytics is great for answering a lot of questions. It doesn't really dive into the why behind why consumers are making these decisions. So those were probably 3 very concrete steps that were taken. Find me at the happy hour. If you have anything else, I'm happy to talk more. Thank you.
Thanks a lot, Jaysen.